Hi, everyone. My name is Mahadi Osukai. I'm the Chief Operating Officer and co-founder of IdeaSTEM. I'm going to talk to you today about a mathematical concept called the bell curve. And I'm going to, in the time that we have, demonstrate to you with lots of complex math that there's no such thing as the average person. There, I said it. I'm going to prove it to you. But first, a personal example. I was a prodigy growing up. I started grade 9 here in Canada when I was all of 10 years old. Today, they call kids like me Sheldon Cooper. No, seriously, they call kids like me twice exceptional, or 2E. And there's starting to be a growing recognition of the fact that kids with disabilities can also be gifted. But for a long time, if you were a kid with a disability, you were thought to be on the left side of this thing called a bell curve for absolutely everything, and how dare you be on the right side of that curve for anything. So, what is this bell curve of which I speak, you ask? Imagine for a moment that you have a large enough population of human beings, thousands of people. Say, what you're going to do now with this group of thousands of people is you're going to measure something, and you're going to measure something that's called a continuous variable in mathematics. So what that basically means is you're going to get a number, and that number can range from x to y and every point in between, right? So you're not just talking about categories like 1 of something or 2 of something, or blue of this and green of that. You're actually talking about a number that will range from, say, some minimum to some maximum, say 0 to 100 or whatever, right? So this notion of a continuous variable is different from what we also call in math a categorical variable. A categorical variable is things will fall into bins. They'll fall into categories. So blue eyes, green eyes, black hair, brown hair, red hair, those are all categories, right? So hair is a categorical variable. Hair color is a categorical variable. Eye color is a categorical variable. Gender is a categorical variable, right? Height, weight, those sorts of things are continuous variables. So you are measuring some trait, some characteristic that is a continuous variable, and you're doing this across a large enough population, you're going to get a range of values. And when you actually graph that distribution, you calculate something called a frequency distribution histogram. And so you're plotting on the x-axis what the value is. Again, it ranges from whatever your minimum is to whatever your maximum is. And on your y-axis, you're saying, well, how many individuals fall at that specific value? So you have a frequency. Then what you end up with, if you plot your frequency on the y and value on the x, you end up with a curve that actually looks like a bell. That's why it's called a bell curve. It's a symmetrical curve, and its highest point is right in the middle, and it tails off to either side, left and right. In statistics, this thing actually has a fancy name. It's called the Z distribution. We know it collectively in society as the bell curve. The bell curve has all sorts of fun implications, which have permeated society for good and for ill. One of those double-edged swords is there's this notion of average. So the center of the bell curve is the mathematical average of the value that you're measuring, right? So that notion of average is the center of the curve, and most people lie close to that mathematical average, right? And as it turns out, the average is actually the point on the x-axis where the frequency in the Z distribution is actually highest. So you have this sort of subliminal association going on where average is middle and average is highest, right? The highest point on that curve. So related to this is this notion then, because of how we are thinking about average in the context of this curve, that average and normal are actually the same thing. Now, what doesn't help matters is that another name for the Z distribution in math is the normal distribution. But in this case, the word normal is a mathematical term. It's not one freighted by human value judgments. We're human beings who put value judgments on absolutely anything in the English language. including words like normal, but we're not doing that here. It is a mathematical term. So on top of all of this is an interesting logical fallacy that's crept in with respect to how we think about how the bell curve works. So if you're close to the average value for one characteristic, we think, you have to logically be close to the average value for any other characteristic that you actually want to measure. And in fact, you have to be close to the average value for all of them. There's nothing in the math that actually says that that has to be the case, right? There's no mathematical law that says that, but there is a logical fallacy in how we think about this as a society, and that's one of the things that contributes to that logical fallacy. Now, this is where the whole notion of this thing called the average human being comes from. Except this hypothetical creature is quite mythical. The average human being doesn't exist. Here's how we know that. Imagine for a moment that you want to identify the person or people who meet this idea of the average human. You recognize that men and women have different body plans, biologically speaking. So biological males, biological females have different body plans. And you gather thousands of volunteers of both biological sexes. And what you're going to do then is you're going to weigh and measure them across a whole bunch of continuous variables. Let's say you take about 100 continuous variables to describe the human body, and you're going to measure them across you're going to measure thousands of people across those 100 variables. Thousands of biological males, thousands of biological females. You gather all of this data, and then you do math, right? You plot distributions for everything, and yay, they're all bell curves. So you figure out your mathematical averages. You keep in mind that you have the data for males separate from the data for females. You're not mixing and matching things. And then you go looking for those humans who actually have data in your big spreadsheet that fit those mathematical averages that you've just calculated. Guess what you find? You don't find any. No males, no females, nobody. Somebody almost 100 years ago actually did this experiment and discovered this incredibly, to the human mind, counterintuitive fact. There's absolutely no such creature as the average human being. But here's the kicker. We subconsciously believe that this person exists despite the evidence to the contrary. And then we plan for this mythical creature in everything that we do. Employment, education, healthcare, social services, voting, shopping, sitting, sleeping, eating. The real underlying challenge is how we conceive of people who are not average. Human interpretations of the bell curve frame differences. Mathematically, again, the term is deviation from statistical norm. So these are math words. They're not English words. But in English, we consider these deviations from the statistical norm as a deficiency. Whether you're to the left of the curve or to the right of the curve, it almost doesn't matter. You're just not in the middle of the curve. And in the middle of the curve, you're ideal because you're average. And so being to the left or to the right is a deficiency. This also underpins biomedicalized models of disability where persons whose cognitive, sensory, or motor functions fall outside the middle area of that curve, and those persons are labeled as abnormal, disordered, impaired. It provides justification for exclusion. Those who learn or process information differently are devalued, reinforcing ableist ideas. This bell curve ends up being treated as a law of nature, and I'm just going to air quote that for emphasis, law of nature, rather than the mathematical model that it is. It gets applied to everything, even categorical variables, funnily enough, and it's applied in every circumstance, even when it shouldn't be. So, for example, lots of things about genetics in populations do not follow the normal distribution. Very different math applies. And this is where it's hard for someone to imagine how a blind kid who was also neurodivergent, but I didn't know that at the time, could also be a prodigy. The solution in our world is a simple one, even if it's a very difficult solution to implement. We have to constantly remember that the bell curve is a mathematical model with a specific purpose. And so let's not inductively apply it to absolutely everything under the sun. Everyone is really unique. Everyone really is different. And everyone, therefore, interacts with the world differently. What do you think would happen if we planned for things with that mindset as opposed to the one where the average human being exists? Thank you.